Okay, over to you, James. I said that you are probably the one who has posted or have submitted and presented most papers in the COSE seminars over the years, but your experience really spans from being a practitioner, systems engineer at AT&T, and wrote the guidebook for systems engineering in the 90s, then got engaged in the standards working group, and particularly have been over here also in Sweden a number of times to present and on the architecture frameworks, MODAFs and DODAFs, etc. So I think you're one of the people who have the widest range of on your portfolio here. So I'm really looking forward to this seminar. So you may want to add something on your background, but it's all over to you. Thanks.
Okay, thank you, Tom. Yeah, so I think you need to stop sharing. It won't let me share.
Okay, what with that?
Okay, so looks good on your end.
Looks good.
Okay, so I'm a member of the Revision Task Force for this standard for the Unified Architecture Framework, and I will be giving an overview. First, I'll start off giving some basic concepts for the framework itself, and then go into the guide that goes with it, because the guide is a new component of the standard. Okay, so and by the way, I will be in Sweden, in Gothenburg, in October, attending the MBSE symposium. So if anybody wants me to come talk to your organization while I'm there in the area, I'd be happy to do that. So Tom can get you in contact with me. So let's get started. So the Object Management Group is the publisher of a number of modeling standards. The one most of you know about is probably SysML. It's actually a UML profile. UML is a software modeling language. So SysML is a modeling profile built on top of UML. It's a general purpose modeling language for system engineering, where the UAF is a modeling profile built on top of SysML and UML, but it's specifically designed for modeling enterprise. So you can see the kind of things that are relevant for an enterprise, such as the strategy. The strategy is very important for an enterprise, the capability deployed by the enterprise, operations, program, and projects. An enterprise might be a user of business services, mission services, various resources applied to delivering capabilities and implementing operations, and other things like security personnel, organization, and standards. So I'm going to focus obviously on that framework. So I'll just start off by saying that UAF has 230 stereotypes defined, built upon the basic stereotypes within the SysML modeling language. So if you want to model an enterprise or model a business or model a mission, you normally would have to make your own extensions. But if you open up UAF, you may find probably most, if not all, of the extensions you might need for modeling those other things are already standardized. So might as well use the standards. So a lot of people don't realize that this standard exists, and it's actually got a lot of things that could be useful, even for modeling a regular system, as I hope you'll see. So let's start off looking at the modeling landscape. In model-based system engineering, the basic premise is that you're using a modeling language. You're just not drawing diagrams on PowerPoint or Visio, but using a formal modeling language such as SysML provides syntax, which is basically the grammar used for expressing things about the thing you're modeling. The notation is the symbologies like boxes and lines, dash lines, solid lines, arrowheads, and so on. And the semantics is what all those symbols mean. Okay, SysML provides that basic elements, like blocks and activities and interfaces and ports and parts of the blocks, those kinds of things. UAF, on the other hand, defines standard views. SysML has 9 standard diagrams, like a block definition diagram, internal block diagram, parametric diagram, and so on. So those basic SysML diagrams are used within UAF to expand into a number of viewpoints, represent different stakeholder perspectives, and as a result, it defines 72 standard model views. And then for each of those, it provides a view specification that the tool vendors will use to create their plugin so they're fully compliant with the standard. So modeling profile, as I mentioned, is an extension of a basic modeling language. So UAF has actually extended SysML. So you can use SysML to create all those 72 model views, and we call that the UAF modeling language. And just recently coming out is the Enterprise Architecture Guide, which is what we're going to focus on today. And under the foundation of the guide is a modeling workflow, which I'll walk you through that workflow. So every organization has a modeling methodology, whether they have it written down or not, because the modeling methodology is the basis for how modelers and engineers and architects can create architecture models. And from the architecture models, you can generate architecture views that express different perspectives and express how the architecture addresses different concerns of the various stakeholders. And we often get a package of number of architecture views, put it in some sort of architecture description that you can deliver to people. You might put it on contract, you might post it on your web page, or in various forums you can get it out there so people can see your architecture. Methodology can also have modeling patterns and templates built into it. So basic way architecting works is you have to identify who the stakeholders are for the systems you're going to engineer and architect. Stakeholders, by definition, anyone who is impacted either positively or negatively for the solution you're going to deliver. So stakeholders have a variety of concerns about the system. The reason we do systems is to support some sort of missions. In other words, the systems are used to accomplish a job, to perform a mission, to do a task. And once you start using the systems in that way, then the stakeholders will be affected by the way the system operates. And it's a never-ending cycle. As soon as you deliver a new version of a system, the stakeholders will have, maybe they'll be happy, maybe they'll be unhappy. So there'll be positive and negative concerns, and our architect's job is to maximize satisfaction of stakeholder concerns. So we usually can't have the system in front of us, even if we're modifying a current system. The system may be too big to put in your room, maybe too small, it may be microscopic. It may be it may be a global scale system, so you can't necessarily access the system. Even if you could, it's probably operating and no one will let you do experiments on the system to try to figure out ways to change it. So we usually characterize the system in terms of its architecture, which is the fundamental properties or concepts of that system. And the architecture fundamentally provides capabilities for performing the various missions that you have in mind. So the architects have in their toolbox two kinds of things, viewpoints and views. And if you're using the Unified Architecture Framework standard, it defines these 8 standard viewpoints. So if you're familiar with other frameworks like the NATO framework, the NATO Architecture Framework, or the MOD Architecture Framework, MODAF, or the DOD Architecture Framework, they have pretty much those same views, although DODAF didn't have a security view, so that's an additional thing that's been added. So UAF has evolved over the years, and we'll talk about how it evolved from prior frameworks. UAF also defines a number of standard aspects. And an aspect is, you think of it as like the different dimensions of a system. There's the structural dimension, or what are the components, how they relate to each other. There's the connectivity, how they interact with each other. There's the process states and sequences, which is the behavioral aspects. There's the information that flows within the system. There's the parametrics, constraints, roadmaps, and traceability. So given those various viewpoints, the viewpoints represent different perspectives of stakeholders. So you might have the operators as one stakeholder, and then there's the operational viewpoint that represents their concerns. The resources, the hardware and software engineers, there's viewpoints for resources that represent the perspectives of the engineers and the people who build those, like manufacturing and testing. We organize these aspects and viewpoints within a two-dimensional grid. So you can see across the top, the columns represent those aspects. We already mentioned the structural on the left and the behavioral aspects in the middle. And the different rows of the grid represent the different perspectives of different stakeholders. So in the cells of the grid, we have the view specification that's used by, that will be in your tool when you're using the UAF plugin. So if you want to create a resources processes view, you go into the tool and open up the view specification for that and start creating your diagram. And we use a 4-letter designation to identify those views. So RSPR represents RS for the resources viewpoint and PR for the processes aspect. So that makes it a little bit easier, more intuitive for people, because in DODAF, no one remembered what an OV5 represented, or SV4, or a standards view 3. No one would remember those. So using these 4-letter designations helps people remember where they are in the grid. So UAF is actually a 5th-generation framework. It goes all the way back 25 years when the C4 ISR framework came out in the US. And other countries had similar framework back then. So eventually the C4ISR framework evolved into being broader than command and control communications and intelligence, surveillance, and reconnaissance into other things in the Department of Defense. And then it finally ended up with version 2 in 2009. And then in the US, the Department of Defense wanted to get out of the standards business, and they realized the world was going commercial. So they went to the object management group and asked, well, can you take over and help unify the DoD architecture framework with frameworks in other countries and also commercial frameworks? So that's what they did. So it took a number of years, but in 2017, they issued the first version of UAF, and we're up to version 1.2, which should be published very soon because it got approved by the board last week. So if you're familiar with DODAF, there were 52 views in DODAF organized by those viewpoints. And now in UAF, we have 72 views. So where do the additional 20 views come from? Well, we have a number of views that are new. For example, the security views here, those are new. The personnel views are new. And I'll mention later where these came from. So you'll see there's a number of empty cells. That's because the contributing frameworks didn't have a view of that kind. But we expect in the future to be filling in this matrix as the need arises to add additional views. In fact, in the new version coming out next month, we do have an additional 8 views, mostly up in the domain here. We've added some things for architecture management. So here's some of the additional features beyond the DoD framework, and actually it's additional beyond. Some of you probably use the NATO framework. The security views actually came from the Canadian framework, and later on were put into version 4 of the NATO framework. Personnel views were the result of they weren't in the NATO architecture framework, but they were the results of some studies that NATO did, because they realized they need to model the human aspects of their solutions. And the resources view is really just an expansion of the system view. So you'll notice there's no longer a system view in UAF. because system is just one kind of resource. So as I mentioned, the Canadian framework is where the security views came from, and the NATO framework, actually the NATO study, is where the personnel views came from. So if you're using DODAF or our NATO framework or even MODAF or any of the other frameworks, you can look at Appendix B of the US specification, and we have traceability to all the contributing frameworks. So the example here is showing the contribution of the mapping of the DODAF views into the UAF views. So for example, an actual resources structure corresponds to an OE4 in DODAF. Operational constraints corresponds to, in DODAF, the OB6A, which was called an operational rules model. Operational structure is actually two kinds, OB1 and 2, within DODAF. Notice there's actually some UAF views that have no corresponding DODAF view because we've done some expansion to include other things that people need. So the bottom line is, if you use UAF as the standard, you automatically get the corresponding views, and if you're really required to use NATO framework or the DoD framework or whatever. Now there's 72 views. You don't use all of them, of course. You have to choose the appropriate ones for the particular architecture effort you're doing. This is a typical selection for the kind of things I do. I mostly do enterprise architectures dealing with missions and high-level capabilities. So we have the capability structure. Think of it like decomposing the capabilities, and the capability roadmap. How are we going to deploy these capabilities over time? And the operational performers and the operational architecture that shows how those performers do their operations. Organizational structure, capability configurations, which is really just a way to collect together collections of resources. So you can call that a system, but in our construct, a system is just one kind of resource. And notice you have other kinds like hardware, software, technologies, which you may or may not even consider to be a system, but they are basic resources that can be packaged together in some sort of configuration. And those configurations are shown on a resource evolution roadmap, which could be a system roadmap or software roadmap or technology roadmap. So there's some basic building blocks that are used within the entire modeling construct for UAF. So these are all building blocks based upon the blocks in SysML, but we've added some additional specific flavor to these behaviors and agents depending on the purpose. So for example, the capability is the ability to do something. So that's the behavior of what the enterprise is capable of doing. And that's focused on why the enterprise does what it does and addresses high-level needs. The operational activities is what's happening in terms of the operational performers. And sometimes we call that the logical architecture or sometimes logical analysis. The functions is how you're going to implement things in those resources to perform those operational activities. And then we have projects to define who, when, and where. In other words, how we're going to realize those resources that perform those functions. So those are the behaviors, but we also have some basic agents defined at the lowest level. We have projects that perform those activities that deliver resource performers. Resource performers implement operational agents, and all these agents will perform the behaviors on the left. And at the enterprise level, we have enterprise phases, or what we call enduring tasks or value streams, that are the agents that are phasing the capabilities. In other words, you will not deploy capabilities all at once. You usually you deploy those in increments or phases. And the functions will likewise implement activities, and the operation activities map to capabilities. And you can think of the operational agents as exhibiting some kind of operational capability, and the resources exhibiting some sort of system capability or software capability, or in general, a resource capability. So these are the basic building blocks, the behavioral ones and the agent ones. So all these things are going to be used within the 234 stereotypes that are expressing the detailed properties and concepts with regard to these 8 building blocks. So the US specification, published by the Object Management Group, has several parts. The view specification is organized by the grid, which I just showed you. The domain meta model, that's what captures the profile of the extensions of SysML and UML concepts in the 234 stereotypes for modeling the enterprise. And then we have the 72 views are in the modeling language, which is based upon SysML. And then the 4th component, which is what I'm going to focus on the rest of the time we have together, the Enterprise Architecture Guide. So let me, I forgot to put it in here, but let me tell you how to get a copy of this guide. So just go to Google and search for OMG UAF Wiki. Okay, so if you just go search for OMG UAF Wiki, you'll come to our wiki page and scroll down to the bottom, and you'll see a section describing the guide, and then there'll be a link. So you can download the entire PDF file of the guide. So, oops, I need to delete that. Wonder how I get rid of that. Oh, let me get my eraser. And there you go. Sorry about that. Messing up our slides. Okay, there you go. Okay, so what do you use the guide for? Well, obviously, it's meant to be a guide for modelers who are going to be building architecture views and models, but it's also helpful since it describes the wide variety of views. You may only do some resource views because, let's say you're a system engineer, but maybe your operational people will do the operational views. So you may use the guide to have some agreement on who's going to do what views individually and which views will be joint. So in the Department of Defense, they have an enterprise architecture that's pretty broad scope, but it's high level. But the U.S. Air Force has an Air Force enterprise architecture that's scoped within just what the Air Force does. So we can use the guide to divide up the responsibilities of the various views within the 2 different architecture models. The same for a commercial company. There's probably a corporate company-wide architecture, and each of the business units might have their own. So the guide can be used to help them to coordinate their work with each other. There may be a government agency that needs to flow down a government reference architecture to the programs within its portfolio. It can also be an agreement between the prime contractors and suppliers. And just like this seminar here, it can be the basis for training. So the methodology I mentioned before is a documented way of building models. So you can use the guide as the basis for your modeling methodology, because the guide doesn't tell you how to do things. It doesn't provide a process, does not provide methods or tools. So you really need to figure out what methods and tools you're going to use in your organization and map that into the workflow within the guide. And as I mentioned before, the tool vendors can use the process guide as to be embedded within their UAF plugin. So we have all these views.
James?
There's always a question of where do we start?
James?
Where do we end?
James, a
And
question.
how are these views related? Was there a question?
Yes. Are you showing, because I'm at least got the components of the UAF specification slide.
Okay, so maybe I need to stop sharing and reshare and see what's going on here. Let's see. So which slide do you see?
I see the one with the
What's the title?
Components of the UAF specification.
Okay.
Yeah.
So let me go to that and let me see if that now does that advance, or is it still stuck?
I'm still stuck at it. If somebody else could verify that they.
I am also stuck.
Yeah,
on the same page.
Okay. So let me stop sharing and I'll reshare.
Yeah.
Okay, thanks for letting me know. Okay, so now what do you see?
Now you get it.
The grid.
Okay, so let me just go back one slide here. Probably because I was annotating. So I was just talking about the three different uses of the guide. And by the way, the slide deck will be posted later, and you'll get a notification of how to get the slide deck. So I was talking about the questions come up as, where do we start in this? Do we start at the top and work down? Can I start in the middle? Can I start at the bottom? Do I start on the right or left? Where do I start? Which views do we need? Because obviously you don't want to, you never want to do all 72. It's very, very typical to have only 10 or 12 or maybe 15 at the most. But which ones you do depending on what you're trying to accomplish. And then again, once you pick the views, how are those views related to each other? The guide itself is meant to answer these three questions. So we had to build a workflow, which is, it's not a process diagram. We actually model this within the modeling tool using UAF. So this represents more like a work breakdown structure of all the different variety of work corresponding to the different rows in the grid. So we have steps 1 through 9, and you recognize the names of the rows in the grid. So the lines between the elements, the steps, represent the dependencies between the views. They're not the sequence in which you do the work. In fact, in practice, normally you will have all these steps being done concurrently by different groups. So you will have some people that will focus on, the strategic. This is. Oops, let me just go back here. So you might have your program management or your business development people focusing on the strategy and capabilities and drivers. You might have your operational architects or your mission engineers. You may have your service architects do this. Your system engineers focus on that. You may have your business development people, or maybe your functional managers work on personnel. You might have your security engineers focus on that. You might have a portfolio management group. So in practice, you're going to have different people working on the different steps all at the same time. So one thing the workflow does is to help coordinate and show what the dependencies are between these particular viewpoints. So even though this looks like a waterfall, in fact, I need to update this diagram to show that it really go back and forth. This really represents layers of abstraction. So the higher level viewpoints are more abstract, and eventually you get to the bottom and you have actual resources, things in the real world. In other words, they're as concrete as you can get. You can touch them. Whereas everything above it is really just a definition of the things that eventually get into the real world. But you might find only the operational perspective of those things and how you can operate the things in the real world. You might talk about the services that give the operators access to those resources, or you could just be focused on the hardware and software that gets designed. the personnel aspects, and so on. So here it shows the kinds of information that is involved in each of those perspectives and those viewpoints. So in the middle here, everything here is there in the architecture to implement your strategy in your operations. Think of this as an implementation step. So you're going to do analysis of alternatives across, and this is your trade space. You can make some things services, some things resources. You can some things allocated to personnel, and you may need to do some things to make things secure. So if you make something more secure, you might take something out of the hands of a personnel and put it in charge of let's say a security device. So now you no longer have a person as a guard at the front desk. You might have a badge reader. So that's an example of a trade-off between personnel and devices, or the the hardware software. So this workflow is designed to be tailorable. So remember I mentioned it's like a work breakdown structure. So just like at the enterprise level, you might have a standard work breakdown structure, but you only implement parts of it. And each of your programs within the enterprise will also tailor the standard work breakdown structure to the things that are important for them. At the enterprise level, you might go no further than step 5. And even when you define the resources, you'll probably only, at the enterprise level, define them at the top level. So you might say, we'll just define each system as a black box, only define the inputs and outputs, and may not even define what the subsystems are, because on here, for this system, you want these system engineers to have maximum latitude and maximum trade space to deliver a more effective, cost-effective solution to meet the needs of the enterprise. So in the case of System X, they might take the operational architecture at the top level and modify it slightly just for the particular situation for that system. And they might modify some of the service architecture from above. If you go down to this system, they say, oh, we don't need to modify the operational architecture, service architecture. We're going to use those as is. And we just work at the start of the resource level. Whereas on this case, we're going to make some changes to the service architecture, no changes to the operational architecture from step 3. So the whole idea of the workflow is that tailorable, just like a standard WBS template would be on a program. Now let's look at the document itself. We have to put in some of the obligatory front matter. Then the key thing up front is the 12 pages of introduction. We wrote the document for non-modelers, non-engineers, non-architects. So the introduction is to give them some basic background on what we're doing, what is architecture about, what is modeling about, what are the modeling languages, just try to explain some basic concepts. So this is not meant to be a detailed handbook for modelers. You have very large textbooks that tell you how to do SysML, and there's not yet, but there will be someday large textbooks on how to use UAF in doing modeling. So we start off give an overview of the guide, tell them what they expect, and the bulk of the information is in the 10 chapters corresponding to each of the 10 steps. So we have about 8 pages per step. Provides a description of the top level steps, a narrative for each of the second level steps, and a table of the steps that's corresponding to that chapter. So now let's walk through one particular chapter for the step 3, where you define your operation architecture. Looking at the table of contents, you can see we have the top level workflow for operation architecture. In other words, that's just the portion of the entire workflow that relates to step 3. And that portion of the conceptual schema that you would use those modeling concepts for defining the operational architecture. And then in this case, we have 4 second-level steps, those major steps. The first defines the operational concepts. Then you define the operational activities. In other words, that's the behavior. Then you define the operational performer, that's the structure. And then you bring it all together in an overarching concept of operations. How would you use these concepts with this behavioral activities and structural performers? So this is what, if you open up the document, this is what the pages look like. We start off with a narrative for that step, define some of the key terms, provide the workflow that's just for that portion of the overall workflow, and then provide a table at the end summarizing the steps and the corresponding UAF views. So here's the overarching conceptual schema. So this is intended to be used by architects and modelers to explore the possibility of modeling different aspects of your architecture. So this is only 30 or so of the key concepts. Remember, I mentioned there's already there's over 230 detailed stereotypes in the entire meta model. So this is really the top of the pyramid. We use a color coding to correspond to the colors in the grid. So this example here of the service domain. So these are the salmon colored service elements. So you can see, so we're using a simple entity relationship modeling notation to capture this, to make it simple to understand. So the basic thing is a service, which can perform a service function. The service can own a port, and the port is typed by a service interface. So if you're going to utilize the service, you would interact with that service through the service interface. So we also have a service contract, which is going to govern the execution of the service, and we have service policies that will constrain that service. There could be a special case of a service, which is maybe several services work together. So you can define the service architecture. The services perform certain roles, and the services can interact with each other through a service exchange, exchanging different exchange items, including information, and is conveyed on a service connector, which is connecting together these roles. So you can see how you can, understand from a very high level what are the basic modeling concepts that you would use to model services. So this is the conceptual schema diagram we provide in step 3 chapter. These are the basic modeling elements used to define the operational architecture, and also the operational activities, the operational performers, the operational ports and interfaces, the exchanges, the information element, the connectors, the roles, so on. But we also include this stuff over here because these are the resources that will implement these operational elements. So notice the basic pattern here is everything on the right can implement things on the left. So for example, you have a function here, can implement an operation activity. You can have a resource performer that can implement an operational agent. You can have a resource interface implement an operational interface. A data element can implement an information element. So that's the basic modeling pattern. So system engineers tend to work on the right because they're dealing in the resource space, whereas they would probably work with people in operations. It could be mission architects or mission engineers, or it could be operators themselves who help define the operational architecture. So looking at the top level workflow, we can see here are the 4 steps we saw before. And for each of the steps, it corresponds to one of the UAF views for that step. But notice there's also some some views outside this step. So this strategic connectivity view is created in a prior step, but it's used to inform the high-level operational concept. The operational taxonomy defines the operational performers, which informs the service kinds. In other words, the kinds of services in your services taxonomy. So going down one level in the workflow, this is step 3.1, dealing with capturing the operational concepts. So we saw this before, the high-level operational concept. So notice we also indicate in brackets, square brackets, the DODAF designator, because a lot of people are still more familiar with that. At the third level, we have these 7 steps. And then there's the corresponding UAF views for each of those steps. So for example, capture the operational environments, leaders, and operational conditions. That would go into an OV1 that shows the operational nodes within the particular environment. Capture the overall performers, their roles, and structural relationships. That's an OV2. Operational structure. That's where you identify your operational nodes and the need lines between them and show what kind of information flows between those operational nodes. So there's another component of the UAF spec called the UAF sample problem. And for each of the 72 views, it provides an example view of how you might construct that. And this is done for the search and rescue mission. So here we can see in search and rescue, there's some sort of helicopter, some sort of aircraft, there's a rescue boat, and the naval ship. So this is obviously just for the scenario of rescue at sea. So in this case, we have a yacht that is in distress, sends a distress signal, it's monitored by some sort of monitoring station, goes to the control center, and the control center will control the rescue assets. And the next step is defining the behavior, the operational behavior of the architecture. So we can see this has 9 steps. Notice here we're capturing measures of performance, and we have 3 kinds of measurement views. So these are operational measures. So the basic measurement item can be used to measure any kind of element within your entire architecture. So another component of the specification is the modeling language itself, which contains these view specifications. This example is the one for the operational process. So you can see these are the stereotypes that relate to this particular view. So here's operational activity, here's operational method, here's the agent that performs that activity, and you can see there's operational activity actions, which can be measured with a measurable element, which defines in terms of measurement sets. And if it's a service, you can have a required service level for that service that applies to this operational activity action. You can see the operational object flows and control flows. So this, you would never show this to your engineers, but the modelers might need this to help figure out what kind of information that they need to populate this particular kind of view. So here's a sample view provided for search and rescue. Here's your monitoring activity for stress signal. There's the sending of the signal. There's the receiving of the signal, processing a warning order, navigating to the location where the victim is located. And at some point you find the victim and you rescue them. Step 3 is defining the operational performers, and we call this the operational taxonomy. Your OV2 is your basic view that identifies what your performers are and how they relate to each other. Here's the view specification for the taxonomy. So here at the highest level, you have an abstract thing called a concept item, different kinds of assets, or it could be a location. You could have various kinds of resource performers. You could have a resource architecture, physical resource. And the physical resource could be organizational, like a post or an organization, or it could be a resource artifact, like a piece of hardware, or special case being software. Or Another kind of resource is a natural resource. Here's a sample view for the operation taxonomy, showing here's your command and control performer, your distressed party, your searchers, your rescuers. And then here they show that there's a different kind of rescuer in phase 2 than there is in phase 3. In other words, the phase 2 rescuer and phase 3 rescuer probably have new and improved capabilities and new things they can do operationally. Step 4, by convention, the last step is always about some sort of analysis to analyze the operation structure. From this analysis, you would usually generate some sort of concept of operations document. And if you did your modeling correctly, you ought to be able to generate the ConOps document automatically from your model itself. So here's the operational structure, use specification. So we showed the top level flow, those 4 steps for step 3. And we wrap up the chapter with a list of all the steps and the corresponding views. So we looked inside the document, and I gave you the link where you can find the document itself. So the basic challenge for the enterprise managers is how to manage adjust their portfolio based upon the changes in drivers. And you can use the architecture model as the basis for informing those portfolio managers. So we look at the landscape where SysML is your basic modeling language that's been extended with UAF to provide an enterprise modeling language and defining its standard 72 views. So we just covered the enterprise architecture guide. And of course, I can spend an hour on each of the other 3 components if I needed to. So the guide itself was meant to answer these 3 questions. And I'll stop here and see what kind of question do we have. One question is, how is the multi-tier approach implemented in tools? There are several ways. Within SysML, there's a way to have a usage relationship between models. So UAF has you can have different project models. So you can have a system level model that you might model your system in SysML. Then you can have an enterprise level model, and you have a project usage relationship. So at the system level, your enterprise model becomes read-only, but you can connect everything in your system to things in the enterprise. So that's how tools will typically implement this multi-tier approach. There's also another way is you can export your model in XMI format, and then on the other side, they can import XMI. It's not perfect, but it works most of the time. But that's an area of improvement that needs to be worked on. Comparisons between UAF and Archimate for the open group. We have been working with the open group, and that's one of the things we're going to work on this year, is to try to put in the next version better hooks between the Archimate modeling language and UAF. And if you're not familiar with it, Archimate is a simpler modeling language used in the IT architecture for information technology. And what industries are UAF mostly used? Mostly still used in defense and aerospace, but we've been working with Boeing and Airbus commercial. Both of those are using that in their commercial domains. They're in Sweden. There's some work on the service architecture for the electric road initiative there. So that's part of your infrastructure domain. So it's catching on, and there's going to be an MBSE symposium there in Sweden in October, where you can go listen for 2 days to various people talking about how they're using UAF and other MBSE kind of concepts. How is it used in the tech industry like Google and Apple? I really have no idea. The people I've talked to, Google and Apple don't do any sort of system engineering. They're more of a fly-by-wire sort of operation. So I really have no idea how those kinds of companies do things, either engineering-wise or architecture-wise. So I couldn't answer that. So if anybody knows the answer, maybe you could tell us. Are there any other questions? You can go ahead and unmute yourself if you'd like to speak up. or type your question in the chat window. So given that I have a couple more minutes, what's the impact of SysML v2 on UAF? We are planning on UAF version 2 that will be based upon SysML v2. And in fact, we're working on the RFP right now for what are the requirements we're going to put on UAF version 2. Any other questions? So I'm going to quickly go through these slides. Are going to be in the slide that you can have available. But this set of extra slides in the back go through each of the steps in terms of the schema. So here's the modeling elements related to planning and preparation. Here's the drivers and challenges, part of the schema for step 1. Here's the strategy and capabilities for step 2. Here's the operational architecture, which is the one we went over previously. Here's the service architecture stuff. And you can also see how services are connected up to the operational things. Here's the resource architectures, which is your implementation of operations in step 5. Here's your personnel organizational model elements. Here's your security and protection in step 7. Your portfolio management, which is mostly about projects and milestones, delivering various kinds of resources. And then eventually step 9 is where you actually build stuff and put it in the real world. So the actual resources, instantiating those in the real world and mapping those back up into the capabilities you are trying to deliver. And so this is typically used to help with your verification and validation. So there's your entire schema. I will provide the schema diagram. This sits here as a PDF file. So you can post that with the slides so you can zoom into the whole thing. And then some other bonus slides talk about how to do problem framing. I have an INCOSE paper for this from a few years ago. So before you go off and build the models in step 4 and 5, first you have to get ready and collect the data. But before you even do that, you can do these 4 steps to help you identify intended uses, the architecture, scope and context, what information and data, and then eventually helps you identify of those 72 views, which ones will be relevant and useful for your particular effort. So the 4 steps are outlined here, and you'll see more details in the paper I provide. And the basic thing is problem framing. You're trying to identify the high-level questions. I call them business questions, not the questions engineers ask, but the questions usually decision makers ask. You know, in other words, the users of the architecture, what question will they ask? And then the conceptual schema that goes with it. Of course, UAF provides a conceptual schema. So then you would need to take the UAF itself, take the particular schema that the portion that answered these questions, and then you would tailor this and then build your model profiles, which is basically your tailoring in a modeling environment, build your models and views, and then you can use that for making enterprise decisions. So that's all I have for my presentation. Do you have any other questions?
Any additional questions? Well, if not, thank you.
Did you say, James, that you would provide the paper for the framing problem, or?
Yeah, I'll provide that, and Tom will post that somewhere along with the slides.
Perfect.
Yes. Right. Let me just, before we end, and give you a bit of, first of all, thank you very much, James. So we've had some questions and some good answers. And again, what you just presented, 1 hour is certainly not enough to make you a wizard in UAF or know exactly how to apply. But now you got the orientation and you know who to ask when you need in doubt. So, but actually, as James said, we do see some applications of this, and one will be actually presented in our next webinar on the 12th of May. by Hans Nattvig, who will show how he had applied the architecture frameworks, including UAF at the healthcare, actually the hospital in Uppsala. And so that will be quite interesting. And then on the 6th of June, we will have Jennifer Russell, who leads the Smart Cities Initiative Working Group at INCOSE, to talk about what's happening there. Another, I guess, application where UAF would become very useful. So that's happening in our webinars. I also take the opportunity to make a bit of advertising for the Nordic Systems Engineering Tour. And James, you have not joined this one yet, but I think there will be opportunities. Every year we do 2 of these, whenever possible, physically. So this year it looks promising. So we have planned for the 18th, 19th, and 20th of May to do the Helsinki, Stockholm, Oslo tour, and then we have one in the autumn that's preliminary scheduled for 7th, 8th, and 9th of September, then from Linköping to Copenhagen and to Hamburg. So have a look at the website, incose.se, and see what's happening. So again, thank you very much, James, for this quick and very effective, I think, introduction and overview of the guide to how to use UAF. We'll post the slides as James mentioned. I will also post a link to the recording of this video. So that's another possibility for you to go back and recapture some of all the information we got in this 1 hour. Okay, so with that, thank you everyone, and looking forward to seeing you at the next webinar. Right.
Thank you, Tom, for the opportunity, and I hope to see you in September, actually October.
Yes.
Maybe I'll see you in May if I can join your boat tour.
Yeah, no, that would be good too. Yes. All right. So thank you, and I think we stop here. I think people are.
Thank you.
Sort of,
Have a good day ahead.
Yeah. Thank you.
Thank you. Bye.
Bye-bye.
So, James.